Okay, so guys, this video, F-14, is, I don't know, you might decide not to watch it. So if you think maybe you don't want to watch it, go take a look at the notes and just see this is stuff we've been doing before. It's just I'm just like summarizing using implicit differentiation with the formulas that we were doing last cycle. So let me just show you what's taking place in this video. I'm going to do numbers 2, 8, 12, 18, it's blurry, 12, 18, and 22 from the practice. All right, so just one from each row. You don't need to watch it if you feel like you already understand like how to do this. You're basically just using implicit differentiation and the formulas. Okay, so if you're watching, let me do this one. So since they're asking for dy dx, they are implying that y is equal to y of x. So we need a y prime after a y derivative. Okay, so I need the derivative of the secant part. Okay, so I'm going to need chain rule because xy is inside. So for the xy part, I need product rule. Derivative of x is 1, bring down the y, plus bring down the x. Derivative of y is 1, but we need a y prime after a y derivative. And then the derivative of secant of blank is secant blank, tangent blank, and xy goes back in. Okay, that is the derivative of this first term. Now the derivative of the second term is 4, but then you need a y prime after a y derivative, equals 7. Okay, now I'm going to need to solve for y prime. I've got 2 y prime terms. I need to get them on the same side of the equal sign and then everything else on the other side. The easiest way to do this is going to be to distribute the secant tangent inside of these parentheses. So you end up with y secant xy plus xy prime secant xy. Okay, now find the y prime terms. We've got, this is a y prime term, and that's a y prime term. So all I got to do is get this non-y prime term over to the other side, and then I can factor out the y prime. And guys, you could skip, a lot of people can like kind of do this in their head from here. That is fine. Okay, now I'm going to divide, I'm going to factor out the y prime and divide both sides by what is left. Okay, I need more room. Like this. I don't need that much room. All right, and then we get y prime, which is the same as dy dx. Okay, there's that. All right, let me do this next one. I'm going to need okay, so the derivative of this, all right, so it's going to be 2y prime. The derivative of inverse secant is 1 over absolute value of blank radical blank squared minus 1. 2y that's going in there. Okay. Now, let me go like this. So this is 2y prime I'll change it to 4y squared. You don't have to, though. It's actually going to be easier for me to write. If you want, guys, you know, you could put that over 1 and think about cross multiplying. So 2y prime equals x squared. And then we get that y prime is all over 2. Okay. All right, now this one. I'm just not even going to really talk much. I got to do product rule there. Okay, so 5y plus 5x y prime times, all right, the derivative of this one is 1 over blank. And then the 5xy is going back in. So the derivative of this inside gets multiplied by that. So this is all just going to end up being over 5xy. Okay. Plus 4 equals 6y to the 5th y prime. All right. So we've got a y prime term here and a y prime term there. I think what is probably the best thing to do, let me think. I mean, there's a few ways you could handle this. I'm gonna subtract this 4 from both sides, and then I will be able to cross multiply. Or we could put everything over 1 and cancel the denominator. That would work also. Shoot, what would I do if I was on my own? If I was on my own, I would just get common, I would just cancel the denominator. All right, so yeah, so let's do that. So I'm going to multiply, I guess I'll multiply this whole thing by 5xy. I'm multiplying the entire, every term of the equation I am multiplying by 5xy. You know what, let me do it like this. This is probably more exact if I do like both sides. All right, so I'm multiplying both sides of this by 5xy because that's going to allow me to cancel this denominator. And then that's going to get me closer to getting my y prime terms on the same side. So this is 5y. I forgot how heavy the algebra was in this. 30 xy to the 6th y prime. Okay, so now at this point, we've got a y prime term here and a y prime term there. So this is 5xy prime. Okay, and then I'll factor out the y gonna need chain rule. Right, this derivative is just negative e to the blank, and then xy is right. All right, so the derivative of this, I need product rule. So y plus xy. And then that's derivative of the inside. Derivative of the outside is negative e to the xy. Derivative of this is y prime. Product rule here. Okay, so I actually have 3 y prime terms. I got to get them all on the same side, but first I've got to distribute this into here so that I can do that. So this is negative y. Okay, so here are my y prime terms. I'll get them all over on the left. I'm going to factor out a y prime. Okay, and then I'll move up. Get that y prime. Okay, and then this one. Out. Natural log of 6, 6 to the blank. Okay. So the derivative of 5y is 5y prime. The derivative of this one is 1 plus y prime, derivative of the inside, times the derivative of the outside, which I already did over there. And then the derivative of that part is 8x to the third. Okay, I gotta solve for y prime. So I've got these 2 y prime terms. I need to distribute this in order to get the y prime terms by themselves. Okay. So now y prime term, y prime term. Okay, and then I factor out the y prime. One more step. Gosh, it's so much writing. And then this becomes, okay, so we've got y prime, gotta write small, 8. Oh boy, okay. That is a lot of writing. Okay, guys, so the hardest part about that was probably the algebra. Maybe the most tedious part was probably the algebra. Okay,